Hello everyone, welcome back to my channel. Today we will be solving Leetcode problem 3097, which is shortest subarray with or at least k. Okay, so what does the problem statement states? We have been given an array nums of non-negative integers and an integer k. Okay, an array is called special if the bitwise or of all its elements is at least k. Okay, whenever we do or bitwise or for all the elements, if the value is equal to k or is greater than k, then we call that array as a special. Okay, and we have to return the length of the shortest special non-empty subarray of nums. Okay, if we don't find any such subarray whose bitwise or of all elements is not at least k, then we have to return -1. If we found any such subarray, okay, we might find multiple subarrays which are special, but among those subarrays we have to return the length of the shortest special subarray. Okay, now let's get back to an example. Okay, let's take this example. We have an array of 1 2 3 and we have given a k value of 3. Okay, now what all subarrays can be possible for this particular array, which is 1 1 2 1 2 3, right? And we have 2 2 3 and 3. These are all the possible subarrays for the given array, right? If we find or, right, this is a subarray with only one element, so the or would be 1. This is a subarray with two elements. If you find or, it will turn out to be 3, right? So this is one such subarray whose bitwise or of all elements is 3 and which is actually equal to the k, right? So this is one of our solution. Okay, now let's take this one. Okay, if we do or operator among all these elements, we again get value as 3, which is again equal to our target, which is k, right? But we have to return the length of the subarray whose bitwise or is at least k, and it has to be the smallest. Okay, if we compare these two, this is the smallest one, right? So far 2 is the answer, right? But if you go further, this is the subarray whose bitwise operator is 2. It is not equal to or greater than k, so this is not the solution. And if you see this subarray 2 or 3, right? 2 or 3 is actually 3, which is actually equal to k, but so far we already have the shortest one, so we don't have to update our solution. And the last subarray whose bitwise or is actually 3 and it is the smallest one, right? So far we have two subarrays whose length is actually 2, but we found another subarray whose length is actually 1, right? So the answer would be 1 here. So this is the smallest subarray whose bitwise or of all its elements is at least k. Let's take one more example. We have 217. Okay, we have 2 21 213 1 18 and 8. These are all possible subarrays, right? So if you find bitwise or among those elements, for 2 it is 2, it is not greater than or equal to k. For 21 it is 3, it is not greater than or equal to k. For 218 it is 11, it is actually greater than or equal to 10. So this could be our possible solution. Let's also explore the other subarrays. For 1, the value is k, which is not greater than or equal to k, so this is not the solution. For 1 and 8 it is 9, it's not the solution. For 8 it is 8, right? It is also not greater than or equal to 10. So we have only one such subarray whose bitwise or is actually greater than or equal to 10. So the length would be 3 and this is the solution. If you see the approach which I have taken, I have basically generated all possible subarrays and trying to find the bitwise or for each element, right? So what would be the time complexity in this case, right? It would be order of n square. So for the first time we will be traversing all the elements, right? 1 1 2 1 3 and next 2 2 3 and next it would be 3, right? It's order of n square. We have 2 for loops over here. So can we do anything better over here? So order of n square is not a better solution. Let's try to think how can we improve. So if you see, like we can use here sliding window approach. Okay, so what we can do is basically we'll keep a variable, we'll have a variable which will store or what is the or among all the elements which we have seen so far. Okay, so first we have encountered one. Let's take this example, 1 2 3. So first we'll have our left and right over here. Okay, what we'll do, we'll try to increase our window. So initially our window size is 1. Next we'll try to increase our window until and unless we hit our criteria. Our criteria is to have the OR of all the elements which is greater than or equal to k. Once this condition has met, we'll stop increasing our window and we'll try to shrink the window. Okay, so currently when we have one element, when we are starting, so current OR would be 1, right? 1 is not greater than k. 1 is not greater than k. K is actually 3 here. So 1 is not greater than or equal to 3. We'll try to increment our right pointer. Okay, so the right pointer would actually come over here, and so 1 or 2 is actually 3, which is actually greater than or equal to 3, right? Here itself we have met our criteria. So what would be the length of the subarray? The length of the subarray would be right minus left plus 1, which is right is at this particular index. So if we make it as 0 1 2, 1 minus 0 plus 1, which is actually 2. So the length of this array is basically 2. Okay, so we want to find the shortest length, right? So the current length is 2. If we encounter any subarray which is less than or equal to 3, we're going to update our variable. Okay, so since we met our criteria, we'll try to shrink our window. Okay, current window size is 1 and 2. So we'll try to increment the left pointer. Okay, when we are incrementing the left pointer, whatever or we have to eliminate the element which is on the left. Okay, so if we exclude 1 from the OR operator, so far OR, okay, we will only end up with 2, right? So the current OR would be 2. Is it greater than 3? No, it's not, right? So we'll again increment the right pointer. So we have 2 or 3, which is actually 3. Is it greater than or equal to 2? Yes, it is. So in this case, since we have met our criteria, we'll first update our length. What is our length? Here in this case, right is 2, left is basically 1 plus 1, which is actually 2. So far we have a length of 2, and currently we also have a length of 2, so we don't have to update. We haven't encountered the shortest window yet, right? Since we have met our criteria, we have to shrink our window at this particular point of time. So previously we have left over here, so we will basically remove our left. So we only have one element in our array, which is 3. 3 is basically greater than or equal to 3. Yes, it is correct. So we'll try to identify the length. The length would be 2 minus 2 plus 1, which is actually 1. So the length of the subarray would be 1. So we'll actually update it to 1. So the main idea is to increase the window when we meet our criteria. Increase the window until we meet our criteria. Once we meet our criteria, decrease until our criteria will not meet, and update accordingly the shortest length. Okay, so let's jump into the coding.
Yeah, I'm back to my Leetcode. Let's jump into the coding part. Okay, so as we have to return the shortest length, let's define a variable called shortest length, and let's define its initial value as max value. Okay, and let's have a variable called length, which is basically the length of the array. Now we need two variables. One is left and right to define the window. Let's have left as initially both will be 0. Okay, and we have to go all the way till the end of the array, and then we'll increment our window. Okay, so first is whenever we are doing or write, we have to somehow store what all bits were set so far. Okay, so let me have a variable called set bits, and set bits of length 30. The reason I'm taking it as 30 because every element in the array can, the maximum value of each element is, it can be maximum of 10 power 9. So uh, if we convert, so if you have 30 bits, right, 30 bits would be sufficient to store all the values from 0 to 10 power 9. So how do I calculate this? Is basically you can do log 10 power 9 base 2, then you will basically get 29 point something. So if you round it off, it is 30. So we basically need 30 decimals, 30 positions. Okay, so what I will do for at every point of, once I increment my window, I have to set the bits. Okay, once I have set the bit, I have to check whether I have met my criteria or not. My criteria is basically uh, whatever we have to basically, whatever set bits we have to convert into the number. So the number formed by the set bits, is it actually greater than or equal to k, and left is less than or equal to right. So and as long as this condition meets, I have to basically update my shortest length. Okay, shortest length would be minimum of shortest length comma right minus left plus 1. Okay, so I have to continue this process until and unless any one of these criteria does not meet. Okay, so here we have to basically shrink the window, right? We have to decrement our left pointer. Okay, so when we are shrinking, we have to unset the bits which were previously set, right? So let's note it down: unset the bits and also shrink shrink from left. Okay, so we have to write these two functions. Okay, and once the entire process is done, I have to basically return the length, right? So I have to return the shortest length. So here the shortest length can be equal to the integer max if this condition was not met for any of the, for the entire array. In that case, I have to basically return -1. That means no such subarray follows the special criteria which they have mentioned. If it is not equal to integer max, that means we have encountered at least one such subarray which satisfies the criteria which I mentioned. So let's try to write it down, this function, which will basically takes set bits. Okay, and yeah, we have to return a number. Let's have the initial value as 0. Okay, we'll go all the way till the length, and if any, at any position, if it was set, right, then only we have to include it in the result. So how can, if the set bits of I, if it is greater than 0, right? Then only I have to include in my solution, and so I have to basically left shift it by those many bits, right? And then include it in my number. If I have to include it in my number, I have to do OR operator, right? So, and this would basically populate all the positions, all the bits in this particular number, and then I have to return it. Now let's write a function called update bits, which will basically take the set bits as an input, and it also takes the number. And whenever we are setting, we want to, whatever bits which were previously set, we have to increment those bits, right? So whenever we are unsetting, we want to decrement the bits. Okay, set bits, and it's gonna take the left element, whatever the bits which were set in this particular number, we have to go to each and every bit and decrement it by one, whichever bits were set in this particular number. Okay, let's write it down, that function update bits. It's gonna take the first parameter as set bits, and it's going to take a number, and it's going to take a value by which we want to increment or decrement the values. So we have to iterate through the set bits, and if a particular bit was set, okay, if a particular bit was set, then this value would be 0. We are it should be AND. Okay, if 1 left shifted by I would basically give me 2 power I, and if we do AND operator, and if it is greater than 0, that means the ith bit in this num was set to 1. Okay, in that case all I have to do is basically add the delta, either we want to increment or we want to decrement. Okay, I guess we are done with our function. Let's try to submit this. Okay, we have to increment the relevant position, right? So somewhere we are not incrementing our decrement, so here we have to increment our left window. Okay, increment the left pointer so that we can shrink. So we are not doing that before, we have to shrink the window. Yeah, now it has passed all the test cases. Let's try to submit it. Yeah, it has passed. Yeah, thank you. Do subscribe to my channel for more such videos. Thank you.